In this example, we have given the product of the trigonometric function. So we have secant square theta times 7th power of tangent theta on the integrand, right? And then so our goal is to evaluate this integral. So there may be a couple of other ideas we can use. One of them we want to apply here is the substitution rule. So if we want to use the substitution rule over here, I just want to see what could be the proper substitution that actually help us to change this given integral into a much more simpler integral. So I just want to try with maybe supposing let's say the tangent theta that we have given over here, that function, I just want to suppose that by, let's say, u. So if I suppose the tangent theta is u, then actually I can compute the differential du, which will be the derivative of tangent theta, which is secant square theta, but not only that, multiply by the differential d theta, right? So that would be my differential du. So this is how I always compute the differential du. Once we have, let's say, u equal to some, let's say, some function, here we have tangent theta, the differential du can be computed by finding the derivative of that function. So derivative of the tangent theta is secant square theta, and then we just need to multiply by differential d theta. So we have that u and then differential du. So with the help of these two relations, let's try to see if we can change our given integral into a much more simpler form. So let's just try to substitute and then see how will this change. Okay, so let me have the integral sign as it is. So since we have supposed the tangent theta is actually u, so why don't we just substitute that over here instead of that 7th power of tangent theta. So if tangent theta is u, then a 7th power of tangent theta would be u to the power 7, right? So that's how we can substitute. Then when we do that, then actually after that what is left over is just this product over here, secant square theta times differential d theta, and that's exactly what we have over here on this second relationship, because we have secant square theta is actually differential du, right? So if that is the case, instead of the secant square theta times differential d theta, we can substitute that by differential du, right? So just from this relationship over here. So if that is the case, instead of actually, let's say, evaluating the given integral, we could just integrate, let's say, u to the power 7, which is actually much more simpler than the given one, right? So at the given one was the product of some trigonometric functions, so it didn't know how to find the entire derivative of that directly, right? Or maybe even by some other rules or something like that. But this basic substitution, right, the variable substitution, help us to change the given integral into a much more simpler one. So now actually we can do here, there is u to the power 7, then as we know the power rule of the entire derivative is what? So if we have let's say x to the power n, right, the entire derivative of that can be written as x to the power n plus 1, right, and then multiply by the reciprocal of that, or let's say divided by n plus 1, however we gonna say that. And but this formula works for every other power except then -1, right, in the power. And then we have here in our power is 7, so we can just use that rule over here to find the entire derivative of u to the power 7. So by using the power rule, then how can we find? This will be the entire derivative, this will be u to the power 7 plus 1, right? So 7 plus 1 is now then 8, and then divided by that power, or we can say just multiply by the reciprocal of that. So 1 over 8 times u to the power 8 plus c would be the evaluation of that integral. So we are done here, but the given function is actually as a function of theta, right? So over here it is, everything is function of theta. Our answer is in terms of u. So why don't we change that in terms of theta, and then that can be done from here. This substitution that we have used at the beginning, we have suppose u is tangent theta, so why don't we replace back over here u by tangent theta. So if we do that, then we'll come up with 1 over 8 times 8 power up, let's say, tangent theta, right? So that's what we'll have, and then plus c. So that's it. So this should be the evaluation of the given integral.